Now we are going to see the problem on split muff coupling, and this problem is exclusively to find out the diameter of the bolt. Why? Because the split muff coupling design is problem is finding out the diameter of the shaft, finding out the diameter of the key, finding out the dimensions of the hub, which will be done same as the muff coupling. So this is the problem exclusively to find out the diameter of the bolts which are used in the split muff coupling. So if you see the problem here, find the diameter of the bolts used in split muff coupling to transmit a torque of 2865 Newton meter, and the diameter of the shaft is given as 75 mm, and tensile strength of the bolt is given as 70 megapascal, and the number of bolts here used as given as 6, and the coefficient of friction between the shaft surface and muff surfaces is 0.3. And if you write the data here, so here torque value is given, we are taking the symbol for torque as capital T, that is 2865 Newton meter, and this Newton meter torque is must be converted into Newton mm. Why? Because we require the diameter of the bolt in mm. So if you convert, that is 2865 into 10 to the power of 3 Newton mm. Why? Because 1 meter is nothing but 1000 mm, and if you write that 1000, that is nothing but 10 to the power of 3 here. And the next given value is diameter of the shaft is given, and here we have written diameter of the shaft, and the symbol we are taking as small d, that is 75 mm, and tensile strength of the bolt is given 70 megapascal, and here we have written tensile strength of the bolt, symbol we are taking it as sigma t, that is 70 megapascal, and the 70 megapascal is converted to 70 Newton per mm square. And the next given value is number of bolts is given and coefficient of friction given, and number of bolts we are taking the symbol as small n, that is 6 given, and the coefficient of friction between the shaft and muff surface is given 0.3. And you know that to find out the diameter of the bolt here, we know the basic formula: torque transmitted in the case of the split muff coupling, the formula that is which we have discussed already in the design procedure of the split muff coupling, that is pi square by 16 into mu into dc square into n into sigma t into d. So here mu is the coefficient of friction, dc is the core diameter of the bolt, n is the number of bolts, sigma t tensile strength of the bolt, d is the diameter of the shaft here. And if you substitute all the values here, so that is nothing but this, we have substituted the torque value in Newton mm, and we have substituted mu value 0.3, number of bolts 6, sigma t given as 70 we have substituted, and diameter of the shaft 75 mm we have substituted. And if you solve this equation, you will get a DC value as 22.2 mm. So this is the core diameter of the bolt. You know that core diameter of the bolt we have already discussed. It is the minimum diameter in the bolt, that is corresponding to the roots, that is DC. This is the DC value, that is core diameter of the bolt, and this is the major diameter of the bolt D. So see here, this 22.2 mm is the core diameter of the bolt, which we got by solving this equation. But this is not the standard value of core diameter. If you see the standard value of the core diameter of the bolt DC is nothing but 22.32 mm, and corresponding to this standard core diameter, the nominal or major diameter of the bolt is nothing but 27 mm. These two values are standard values from the tables or data book we can refer. So here, so diameter of the bolt, we can say that M27 is the diameter of the bolt we have to use in this case. Thank you.